Hello and good morning to everyone. So our today's lead code question is 1545, which is find kth bit in nth binary string. So in this question we are given two positive integers n and k. So the binary string sn is formed such a way such that s of 1 is always equal to 0, and then s of I is equal to s of I minus 1, then concatenated with a 1, and then reverse and invert of s of I minus 1 for all I greater than 1, and we have to return the kth bit in Sn, right? So let's see how s of 2 will be formed. So s of 2 is equal to s of 1 plus character 1 plus reverse invert of s of 1. And what is s of 1? S of 1 is 0, so 0 1. And what is invert of 0 is 1, and reverse of 1 is also 1. So see, s of 2 is 0 0 1 1. Then s of 3 is directly s of 2 plus character 1 plus reverse of invert of 0 1 1 is 1 0 0. Now if we'll reverse it, it will become 0 0 1. So see, this is s of 3. Similarly, we find s of 4 and s of n. So let's see the examples. So in first example, we are given n is equal to 3 and k is equal to 1. So we know if the first character is always 0, so we'll be returning 0 directly. Then n is equal to 4 and k is equal to 11. So s of 4 is this string, and the 11th character is 1. So we return 1. So if we'll see the constraints, then the length of the n can be up to 20 and k can be up to 2 ki power n minus 1, right? If you have noticed from the above strings, if you have noticed from these strings, what is the length of s of n? What is the length of s of n? So it is 2 ki power n minus 1, right? See, s of 3 is 7. Length of s of 3 is 7, and length of s of 4 is 15. That is 2 ki power n minus 1. So let's see our approach. So what we are given is, we are given that s of n is made of s of n minus 1 plus concatenation 1 plus reverse and invert of s of n minus 1. So if you see, every string has three parts. That is, left part contains the previous string, middle part is containing character 1, and right part is containing the reverse and invert of s of n minus 1, means the previous string, right? So let's see some examples to see. So see, s of 1 only one character, so only one part, but s of 2 has three parts: previous string, the middle part, and the reverse and invert of the previous string. Then s of 3 is previous string, that is 0 1 1, the middle part, and then invert and reverse of that, that is 0 0 1. So each string has three different parts. And if you have noticed that the right part, that this right part is just the mirror image of left part, but the bits are flipped. So what is the mirror image of 0 1 1? It is 1 1 0, right? If you'll see the mirror image, but they are flipped to 0 0 1, but the bits are flipped. So the right half is mirror of the left half, but the bits are flipped, right? So this will be helping us to make our approach, right? Also, if you have length patterns, so see, s of n is 2 ki power n minus 1, and what is the middle index? So the middle index mid is 2 ki power n minus 1, right? So suppose in s of 3 the length is 2 ki power n minus 1, that is 7, and the middle index is 2 ki power n minus 1, that is fourth element, right? So this is the middle index, and if you have noticed, the middle element is always 1, because we have s of n minus 1 plus 1 plus invert reverse invert of s of n minus 1. So middle element is always 1. So what are the, we make three cases for our k value. So if our k is equal to mid, and as we have already discussed, mid is always 1, so we will be directly returning 1 in that case, right? Then the second case is if k is less than mid. If k is less than mid, that means s of n minus 1 plus 1 plus reverse invert of s of n minus 1. So if k is less than this value, then we directly check in the uh, s n minus 1 string, right? So what we do is we will find in n minus 1 and k bit, right? Because the left half is exactly s of n minus 1, s of n minus 1. So we'll be checking in n minus 1 and k, right? Now the third case, like which is a essential case. So if k is greater than mid, means we are in the right half, and right half is equal to reverse and inverse of s of n minus 1. So if k is in right half, so the image is mirrored to its left side with inverted bits, right? With inverted bits. So what we have to do is, like, well, let's see how we'll be mirroring this. So as we know, our total length is our total length is 2 की power n minus 1, and if k is on the right side, this is the middle element 1 and this is the left side. So if k is on the right side, then what we'll do is, it is also mirror image of previous string, right? Let's now forget that we have reversed the bit or not, though the bits are inverted, but forget that for now. So suppose here we have 0 1 1, then here what we have, we will be having 0 0 1, right? But suppose we haven't flipped the bits, then it will be 1 1 0, right? So how do we find the new k? So here what is the total length? Total length is 7, and suppose we have to find the fifth bit, 1 2 3 4, this fifth bit. So if you see, this fifth bit is the third bit in the previous string, third bit in the previous string here, 1 2 and 3. This fifth bit is the third bit in the previous string. So if k is greater than the middle element, then we update the k such that make it we map it to the previous string. So 7 minus k is 5 plus 1, that is 3 only, right? So we have updated the k. And one more thing is, now we are in the right half. So suppose if this is s of 3, now our k has been updated to 3, then we find s k equal to 3 in s2 string, and s2 string is 0 1 1, and but k is equal to, at k is equal to 3 we have 1, right? But as we have moved to the right part, we also make sure that whatever answer we get, flip that bit to, we flip that bit. So here we are getting 1, so we flip that to 0, so 0 is our answer, right? I hope you get this thing. So let's see an example to uh, make it more clear. So we have to find fifth bit, fifth bit in s3. So s3 is this. So mid of s3 is 4. Now our k value, sorry, mid, not k. This is k is equal to 5, right? So our k value is greater than middle element, right? So we have to find in the right half, right? And as we go in the right half, we have to update k, and we have to make flip equal to true, because the answer that we get, so if flip is equal to true, whatever answer we get, we flip the bit from 0 to 1 and 1 to 0. And if flip is false, then we won't be doing anything, we just return the bit directly. So now our k is equal to 5 and length is 7 minus 5 plus 1, that is length minus k plus 1, that is our new k dash. New k dash, that this k dash bit we have to find in the s of n minus 1. So currently we are in s3, so our k dash is 3 and flip is equal to true. Now what we have to do, we have to find the third bit in s2, and we also have marked the flip is equal to true. So now let's see in s2. So in s2 we have get k is equal to 3 and flip is equal to true. But what is the mid of s2? Mid of s2 is 1. Then again our k is greater than, sorry, mid is 2, because we are starting from 1, 2 and 3. So mid is 2. So again our k is greater than mid. That means again we are in the right half. So again we have to update our k dash. So k dash is equal to length. Length is 3 minus k is also 3 plus 1. So k dash is equal to 1. Now previously our flip is equal to true. So what we do is, again we move to the right half. So we make flip to false, true to false, right? So currently we are in S2. So what we do is, we will find k dash bit in S1, that is first first bit in S1, and as we know S1 is always 0, so we'll be directly returning 0. And as you remember, our fifth bit our fifth bit is 0 only in this string. But what if, suppose here if flip is equal to true, right? Suppose if flip is equal to true, then we are getting 0 na, then we will flip that 0 to 1 in the answer if flip is equal to true. So the next question is, why we have used flip variable. So what we are doing is, so we are, instead of inverting the string immediately, what we are doing is, we are just remembering that how many times we have entered the right half, right? And every time we go to the right side, what we do is, we will negate the flip variable. We will negate the flip variable and store that. And at the end, if flip is equal to false, then we will return the normal bit, right? And if flip is equal to true, then we will return the inverted bit, means 0 to 1 and 1 to 0. So this helps us in avoiding the building actual string. So let's see the code. So we have initially made the flip as false, and then we are using a while loop, that is until n is greater than 1, because for n is equal to 1, we know our string is 0, so1. So see, then what we do is, we'll find the middle element, that is 2 ki power n minus 1, that is the middle element. And I hope you know, right shift means multiply by 2. Right shift means multiply by 2. And then we find the total length, that is 2 ki power n minus 1. So this is the total length. And then we check the three cases, that if k is equal to mid, then we check whether if our flip is true, then we return 0, else we return 1, because always our middle element is 1 ra. But if flip is true, then it may be 0 also, because see, 0 1 0, then 1, and then 1 0 1. Suppose if we go to the right side and then we check the middle element, then see, it is 0. So that's why we check whether our flip bit is true or not. If flip it is not true, then we directly return 1, else we have to return 0. The second case is if k is greater than mid. If k is greater than mid, that means we have to go to the mirrored position of the k on the left part, and we have to invert the bit once, because right part is reverse of invert, right? So our new k is equal to length minus k plus 1, and we set the flip bit as negation of previous bit. So suppose if previous flip bit is false, then now it will become true, and previously if it is true, then it will become false. So if k is equal to mid, if k is not equal to mid and k is not greater than mid, then that means k is less than mid. Then that in that case we directly check kth bit in string sn minus 1. So we just return reduce n by 1, and again check, and sorry, and suppose we don't get our answer in this, then we check the base condition, that is s of 1. So s of 1 is 0, but if flip bit is true, then we flip 0 to 1, else we return 0. So I hope I'm able to explain you the whole approach and everything properly. So if you like the solution, please make sure to like, share and subscribe. Thank you.